Hello, welcome back to this video 5-3, and we're talking relative extrema. This is the second video on 5-3, and we're going to go ahead and jump in talking about how to find relative extrema based upon given a derivative graph. So here, example number 4, it says the graph of h prime is shown above, the derivative of h. On what intervals is h of x increasing? Well, remember, h of x is increasing if its slope, h prime, is positive. So just looking at our graph here, h prime, if I go ahead and make a derivative sign chart, here's h prime, and I go ahead and find out, okay, where is h prime 0? Well, that is at -2, at 0, and that's it. Okay, well, from -infinity to -2, what is our graph? Well, it's positive. Okay, from -2 to 0, what's our graph? It's positive. 0 to 1, oh, I forgot 1. We'll add 1 here. It is negative, okay? And then from 1 to infinity, it is positive. Okay, well, my sign chart, again, this tells us where our function is increasing and decreasing, okay? So it looks like h is increasing on -infinity to 0, union 1 to infinity. And again, I'm not going to break up at -2 just because this would look like a saddle point. And an example of this, again, would be like a cubic function where we're always increasing, but right here, our derivative, our slope, is 0. We call this a saddle point, okay? And they say, give a reason for our answer. Why? Well, because h prime is greater than 0. There you go. H prime is positive. That's how I know. Next, part B. It says, does h have a local minimum, a local maximum, or neither at x equals -2? Well, again, what we want to look for in order to determine extrema is when our function changes from increasing to decreasing. That's going to create a maximum, or decreasing to increasing. That will create a minimum. Now, at -2, I do not change from positive to negative or negative to positive. So our reason here is h has neither. H has neither a min or max at x equals -2. Again, because h prime does not change signs. Does not change signs. C. Find any x values where h has a relative minimum. Okay, well, if I'm thinking about a minimum, that goes from decreasing to increasing. So from decreasing to increasing. Okay, so it looks like at x equals 1. So we can say here h has a relative minimum at x equals 1 because h prime changes from negative to positive. Okay, it does not do to merely state that h prime changes signs. You have to be specific when you're talking about minimums. You have to say from negative, h prime changes from negative to positive, and for maximum, positive to negative. If they were just asking about any relative extrema, you could state h prime changes signs. All right, so that is from a graph, a very common typical question on the AP exam, usually on FRQs, and we'll look at some of those in a moment, but I want to go ahead and go back to symbolic form, or an algebraic representation here. Example 5, let k of x equal x squared over x squared plus 1. Find any relative extrema of k of x. Give a reason for your answer. Okay, so again, step number 1, what we need to do is we need to find k prime of x. So we're going to go ahead and differentiate this, and I'm going to use the quotient rule. We have 2x times x squared plus 1 minus 2x times x squared all over x squared plus 1. And there's a lot going on here, so I'm going to go ahead and just simplify this just to hopefully make our lives a little bit easier, and it looks like it does. I'm going to have some terms cancel. Don't forget your denominator's squared. That's one of the hardest parts for me, man. I always seem to forget that or leave that out. Okay, so here is our final k of x. We have 2x over x squared plus 1 squared. Okay, so what I want to do is I want to know, where is this equal to 0? Okay, this is step 2. Where is k prime of x equal to 0? And that's just going to be our numerator. I'm just going to take the numerator, set it equal to 0. So at x equals 0, it is equal to 0. As well as, where is our k prime? Where is the derivative? Undefined. Now, if I'm looking at my denominator here, I have 2 factors of x squared plus 1. This is never going to be equal to 0. A couple of ways I know this. Just think about this graph. Isn't this a parabola shifted up one? Upward facing, so it's never going to be equal to 1, 2. And then if I tried to solve this, x squared equals -1. As soon as I try to take a square root, we get an imaginary solution. So this never happens. So we only have one critical value. So here is our k prime, and we're at 0. Now what I need to do is I need to go ahead and test. And I'm going to go with old reliable here, -1 and +1. So k prime of -1. If I plug this in, I get a negative over a positive. That's negative. And then k prime of 1, that's going to give me a positive over a positive, right? I'm just plugging these values into my derivative, okay? So they say find any relative extrema of k of x, okay? So what did we find? Well, k has a relative, or it's going to be negative to a positive. That is a minimum. At x equals 0, because k prime changes from negative to positive. There you have it. Pretty straightforward. Okay, awesome. Let's go ahead and look at example number 6. And example number 6, we have a trig function. Ooh, yeah. Got to remember that unit circle, or at least your left-hand trick. So here we go. Consider the function m prime of x, where the derivative of m is defined as m prime of x is equal to 2 cosine plus root 3. Awesome. They give us m prime. That's one less step. Find any values of x where m of x has a local extrema. Okay, so they're only asking for values of x. That's nice. So I'm going to go ahead. I'm going to take m prime of x, and I'm going to set it equal to 0. 2 cosine x plus root 3. Now I'll solve this. Root 3 is equal to 2 cosine x, and it looks like cosine x is equal to negative square root of 3 over 2. Okay, so we want our x value, cosine, this is an x value, to equal negative root 3 over 2. I gotta find the values. So root 3 over 2, if I'm using my left hand trick, again, here's my left hand, I'm going to put down my ring finger. That gives me x values of 3. Root 3 over 2. So this is a pi 6 angle, Now, if I want where x is negative, that's going to occur in quadrants 2 and quadrants 3, right? So I'm pi 6 back from pi, that occurs here, and pi 6 forward from pi. So our critical values are going to be, what do we got? Out of 6, this is going to be 5 pi 6. That's in quadrant 2. And 7 pi over 6. Okay. So there we go. I'm going to go ahead and plot these on a m prime graph. 5 pi over 6, 7 pi over 6. Okay, and they want it on the interval 0 to 2 pi. 0 to 2 pi. So one way that you can do this is you can go ahead and graph based upon your knowledge of the cosine function, or you can go ahead and test values. And I'll show you both, but I'm going to go ahead and talk about testing values. So the best ones to test for trig are quadrantals, if your critical values allow you. So 5 pi over 6, one value I would test is pi over 2. Between 5 pi over 6 and 7 pi over 6 obviously is pi, and then after 7 pi over 6 is 3 pi over 2. So we can go ahead and plug these in. M prime of pi over 2. Here, cosine is 0. So all of that is going to go to 0 plus root 3. So this is a positive. That is positive, right? This goes to 0 plus square root of 3. And then we have m prime of pi. That's 2 cosine of pi. That's going to be -1. So 2 times -1 plus square root of 3. So we have -2 plus root 3. And maybe you're like, hey, I don't know what's bigger. I don't know if root 3 is bigger. Well, just convert root 2 to a radical. Or sorry, 2 to a radical. Isn't this the square root of 4? Negative root 4 plus 3. So the negatives are bigger here. That's going to be a negative value. And then lastly, we have m prime of 3 pi over 2. And again, cosine is 0 down here. So that's 0 plus root 3. This is going to be a positive. So that's one method you can do. The other method is to know, how does cosine look like as a graph? Now, cosine, remember, starts at your maximum, and it will dip down, come back up, and then go back up to your maximum. That's generally how the cosine function looks, right? And it will repeat. Okay, so that idea, if you know the graph of cosine, that can help you realize, hey, this section is going to be positive, here's negative, and here's positive. Okay, so we want relative extrema. Relative extrema. So we can say m has it has relative extrema at x equals 5 pi over 6 and 7 pi over 6 because m prime changes signs. There you go. That is how you know. Okay, so those are most of the examples. What I would like to do now is I'm going to go ahead and show you a couple of AP questions that are from AP FRQs, and they have questions relative to what we were just talking about. I want you to try these, and then I'm going to go ahead and show you the answers. All right, hopefully you had a chance to go ahead and try those. Here are the solutions. Part B, on what intervals is f increasing? Well, f is increasing on -6 to -2, as well as 2 to 4, because f prime here is positive. It is positive, right? So you're looking at an f prime graph on those sections. It is positive. In between -2 to 2, it is negative, so it would be decreasing on that interval. Part C says find any x values where f of x has a relative minimum. Well, it has a relative minimum at x equals 2 because it changes from decreasing to increasing, right? So f prime changes from negative to positive, and we always utilize f prime as our justification. All right, next practice example here is example number 8. Go ahead, please pause the video, and I'm going to show you the solutions here in a moment. Alrighty, here are the solutions to example number 8. Question A, find all x coordinates at which f has a relative maximum. F has a relative maximum at x equals -2. And again, that's because f prime, if I was to make a number line or a sign chart, f prime changes from positive to negative at -2. Okay, so that's our justification. F prime changes from positive to negative. All right. At what are the critical values of f in the open interval, -3 to 4? Well, that's going to be -2 and 1. That is because this is where f prime is equal to 0. Notice I don't include 4 because they say the open interval 4, so I'm not including that value. And then for the last question, on what open intervals is f decreasing? Give a reason for your example. Well, f is decreasing on -2 to 4, and that is because f prime is less than or equal to 0. Okay, so those were some questions from the AP exam. I hope you did well. Again, relative extrema, use the first derivative test. Determine where your first derivative is increasing, decreasing, and if it changes that way, you have relative extrema, or from decreasing to increasing. Give me a thumbs up, like, subscribe, catch you in the next video. See ya.